future of AI isn't just about more data. It's about understanding the connections inside that data. So in this video, I will be explaining you about what is graph engineering and how to build a faster AI workflows. AI agents are becoming more powerful, but simply adding more agents doesn't automatically make the workflow better. The real skill is learning how to structure the work. So instead of making an AI agent do the sequential task where one agent depend on other agent. So instead of doing it, we splitting the task into separate nodes and we merging the tasks and we get the final output. So let me explain you the graph blueprint. First, we have to set a goal, define what we actually want, then split the task into the subtasks. We want to split the main task into the subtasks. Then each task will execute on parallel. And then we use a verifier agent where it checks the agent tasks, whether the agent task has been completed correctly or need to be tweaked. And next, after its completion, we are merging the subtask into a single thing, and we are getting a final answer where where the output is clear and actionable report. So in this graph blueprint, nodes actually do the work and edges carry the result. Let me explain you in the moment. So node, a task that need to be completed. A node carries the task that need to be completed. An edge or the dependency between the two tasks or the two nodes. So there will be the output, which is the structured result. So another task can use it as an input. So if you look at how node actually look like, so node contain an agent, a job to do, and an input to process, and the output that it give. And what is mean by edge? Edge is a dependency between the nodes, so that the edge can be used as a second uh, agent's input. So it can be used for the second agent workflow. And the important part is every node should have a clear job, an input, and an output. Without a clear job, the agent cannot do the task, and building an agent without a clear job is waste of time. So, for example, we are creating a research competitor pricing. So we are creating a research on competitor pricings. So we are giving input. What if you want to research a competitor pricing? We should give an input of the competitor, the name of the competitor, and the URL. So the output will be the pricing plan, the source, and the date which they have updated the pricing plan. Everything it will be giving as an output structure. So the next important topic is does this dependencies actually exist? Dependencies in the sense the similarity between the two nodes, the connections between the two nodes, where the second node actually needs the input of the first node's output. So fake edge test. This is a test we actually do in graph engineering to check whether uh, the edges are dependent between the two nodes. So we are taking the two nodes separately. So for example, if you are checking the bugs in, we have two separate files, and if you are checking the bugs in the two files, the bug in the file one will be different, and the bug in the file two will be different. So if you connect file one to the file two, there will be no use. So file B never reads file A's result. So no data crosses, so no edge. So we should run them at once. We should not do an edge between the two tasks. So for every arrow, ask does this task actually need the result from the previous task? So if you take a node, just ask whether uh, this node currently needs the output of the first node. If yes, keep the dependency. And if there is no, if the answer is no, just task can probably run in parallel. The no need of connecting between two agents or two nodes. Mm, and the next topic is a diamond pattern. So we are coming into the clear part where you understand the graph engineering in detail. So what is diamond part? When we split a task into subtasks, and when we merge after a task completed, we merge the output of each task, we get a diamond structure. We get a diamond structure, and it forms as a graph. And that's a concept behind it. The structure, the concept came from the structure. So we have few technical terms like fan out, run in parallel, reduce, verify, synthesis, which we will go through now. So what is mean by fan out? Split the workflow into independent tasks. So if you take a task, a main goal, the query you give to the agent, you are splitting it into the subtasks, and that process is called as fan out and run in parallel. So after dividing into subtasks, we should make the agent run them in parallel so that they can queue a perfect output. So We should then reduce in the sense removing duplicates or unnecessary information that we does not want or does not need. For example, if you are getting if you need to research on the competitive pricing page, their blog post is unnecessary information, so we should remove that. So we should verify. So each agent should be verified whether the work is completed or the work is not completed. So that helps to maintain the workflow correctly. So synthesize. What is synthesize? We are using one uh, final agent, the only one agent to produce the answer. So we are uh, making a task, we are splitting the task, and we are making each agent do different tasks. Then we are removing the noisy data and making a checker agent which checks the input of each agent, each task, and you are keeping another agent which synthesize and give us a perfect output. So we are dividing and conquering. So the next thing, we should not let the same agent check his own answer because of hallucination and other stuffs. Because if your agent research on a competitor page and if you ask the same agent whether the results is correct, the agents keep on hallucinating. So we should set some constraints on the next agent, and after the agent complete the task, we should check the constraint of the output of the agent. So we should check the constraint whether it satisfy the information that we needed. So we should reduce the noise and we should take only the necessary information. So things graph can also break. So if you have too much amount of information and if you have hidden dependencies and if you have silent failure in the sense where the agent does not work, it fails silently. So we does not look at it. So it fails silently. For example, if you are researching on a competitor's pricing plan, if their website is shuttered down, so if our agent will work, but there is no output when we hit the URL, we does not get any response from the server. So the agent fail silently. So that's about it. So and when should we not use the graph? So if your task is small, we should never touch the graph. For example, if your task is to find the bug in file A, so what do? You just input the file. You should prompt the agent to check the error and correct it. And the task is actually small. So it is sequential. We should not make them AI workflow here. For example, check the line one, task one for checking line one, task two for checking line two. That will be a non, there will be no sense in that. And if the workflow is sequential workflow where each agent output is depend on another agent. So for example, if you take task A, B, C, D, so task B the input of task B is dependent on the output of task A. So if the workflow is sequential, the usage of graph make no sense. And if we control every step, if there is a human intervention in controlling every step, graph is not at all needed. We can separate the workflow, we can do it on our own. And that these are the cases where the usage of graph engineering is not does not make sense. And if you the good AI workflow need external anchors. So we are coming into the important concept called anchors. The graph don't automatically create better judgment. So if you connect with graph, we does not make the graph automatically create does not create the judgment whether the task is correct or not. So we should make an anchor. So we should make the test that actually the agent completed the task, the checker agent, like a checker agent, we should make an anchors where the test the agent actually completed the given task correctly with the certain constraints. So, like if, for example, if you are researching on the analytics in your database, so whether check whether the database, the agent actually gets the real value instead of faking the users. So we use anchors. So agent will do his task by completing a task by taking the fake users. But if you use anchors, the results which your agent give, it will be tested. So it will make the graph more efficient, the agent output more efficient. We are checking it. We are using a test case to pass. There is making an AI agent to passing the test case. And and we are also we can run in your coding agents, like you can run in Cloud Code, Codex, and every coding agent where you can run a swarm of agents where you can swarm up multiple agents. So in Cloud Code, actually, you can use a command called dynamic workflow where uh, it actually divides the job into subtasks, sub-agent. It will span up the sub-agents, which runs in parallel. If you use dynamic workflow, it runs the agents, it runs the task into subtasks, and it makes multiple agents, and it do separate tasks, and it merge the output and remove the noise and make the perfect output that you actually give. So that's a dynamic workflow. So here's a final takeaway of how graph engineering actually works. So first, we have a goal where we have to break the large goal into the subtask, the bounded subtasks, and then we should giving the each task a clear input so that it might produce a perfect output. Then we find each task running independently. So and then which works in parallel. So each agent or task which work in parallel, and then we are reducing the results. We are reducing the noise from that agent which they produce. For example, if you're researching on competitors' pricing plan, the noise, the if you are also the agent also takes the blog post, which is noise, which does not actually need. So you should only take the pricing plan. So we should remove the noise, and we should also watch for hidden shared resources. What are the resource shared between the agents, and we should detect whether the agent fails or it missed some task using anchors, and that's the complete workflow, and then we are merging it and finding the perfect solution. And that's how graph actually works. And we are dividing each task, and we are giving the clear context, and we are testing the context, and we are merging it and finding a perfect solution. I hope you got a clear explanation about graph engineering. And I also wrote an article about graph engineering in my personal website. So I will leave the link in the description so you can learn about graph engineering in detail. So thank you for watching the video, and see you in the next video. Bye.